today I'm going to be doing the editorial for the Knapsack 1 of the Educational AtCoder DP contest. Okay, so let's look at the problem first. So we have n items. They each have a weight wi and a value vi, and you have to find any combination of the n items, and the weight of all the items has to be at most w, but you have to maximum the sum of the values, so maximize vi. And so this is the knapsack problem. It's a very classical DP problem. So let's look at the input. We have n, which is the number of things, items. We have 8, the maximum weight, and here we have, again, the weight and the value. And as you can see here, the strategy is to take 3 and then take the 5. That's the most, because if you want to take 4, you can't take anything else. And so that is automatically less. So let's see what we can do about that. So here's how it looks like. We have a bunch of w, right? w1, w2, blah, 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 wn, v1, v2, blah, 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 vn. So if we try to take these one by one, let's say we have like some database here, right? We know the maximum weight is w. So we can say, okay, for the first one, you either, take it or you don't. So you can say, okay, when my weight is w1, my value is v1. Now for w2, you can either add on to this, or you can not include the first one, right? So you can either have w1 plus w2, which is v1 plus v2, or you can just have w2 which is just v2, right? You can only do this providing this is less than, the max w. And in the same manner, you can do this. You can keep on going down, if the weight is still less, if you add it to any of the previous combinations, then you can add that to the knapsack, and then now you take the total value. And now you keep on doing this, right? Making sure all of these here are less than w, and the one with the maximum combination wins. So how can we do this with a DP combination, right? So what we can do is we know that the maximum, right, weight is w, and let's see what the size of that is. As you can see, w is 10 to the 5th, so we can definitely iterate over that. And let's check how much n can be. N is less than 100, right? So we can iterate over both of these in an array like this. So what we can do is, if we say, okay, given we are considering the first, we're considering the first I items, taking the first I items with this weight, what is the maximum value we can have, okay? And then what you do is when you're taking in a new value, right, wi, or let's say wa and va, all you would do is for j from 0 to w, or 0 to w minus wa, right, because we need to make sure that it's all less than a. And for all of this, for every wa, we would just do dp of j plus WA of, it would be A, right, is equal to, the max of this, max of that, whatever it might be from previous, and this J, and A minus 1, right? Because we're saying, okay, if you take this weight and only considering up to the last item, I want to add to that set, I want to add my new value. And then we take the maximum to, whatever other combination. And then our final value is just, our answer is just dp of w and n, okay? And for this one, you just loop through for I, 0 to n, or n minus 1, right? And then you just go through it sequentially, and that way we will be able to get all the combinations and grab the most. Thank you for watching. I hope this is helpful, and I'll see you in the next video.